Hello and welcome. Optical fibers manufactured in outer space under conditions of microgravity are superior to those manufactured on Earth. Why? Microgravity. And that's the theme, the topic for our fourth research recap for the future. So please, let's dive in. First of all, microgravity is a nuisance for space travel. What is it? On Earth, we know that gravity is about 9.8 meters per second squared. And outer space conditions, the gravitational force is close to zero. So we say microgravity. It's a huge nuisance for space travel because astronauts return with a lot of physiological malfunctions in the nervous system damage, muscular system. There is muscle loss, muscle atrophy, bone loss, bone metabolism is altered, and so many more. In summary, morphological abnormalities in gene expression, protein expression. So microgravity is something that NASA has been working to mitigate because it is a challenge for space travel. But interestingly, it can also be used and has been used and is now increasingly used in a positive way. Made in space, space manufacturing, in space manufacturing. So conditions of microgravity actually favor some aspects of manufacturing. For example, in high precision components, autonomous robotic systems, drug discovery, biomanufacturing, 3D printing in microgravity. Yes, we have a zero gravity printer with spatial properties. Now, the most outstanding for me in terms of made in space, outsmarting and being better than stuff made on Earth is fiber optics. It is now called flawless photonics. As at last year, those fiber optics produced in microgravity have lower signal loss capabilities, enabling long-haul communications. These will also enable better medical applications, for example, in endoscopy, supercomputing, name it, security. Here is a pair of scanning electron microscope images illustrating fiber optics made on normal on Earth with normal gravity and one microgravity. Guess which is which? You heard me say that the one in microgravity has less signal loss capabilities. So see it right there. Less noisy, less crystallization of the materials used in making it and making it have superiority in terms of keeping the signal. So in fact, so far, 10 times better, imagine. There are other applications of microgravity, including simulated microgravity. And that's part of what I have done with some of my research students in my lab, simulated microgravity using a device developed by NASA. So this is one of such devices called a rotary cell culture system that allows us to mimic microgravity in the lab. And that's what we have right there. So in the lab, we mimic it. We have cells, we culture the cells, and we do some physics and math to understand the forces involved. So that's the Navier-Stokes equation. Following the math and the actual experiments, we end up with interesting results. If you culture cells on 2D surfaces, they just stay there, they grow, but all in 2D. But if you put cells in the rotary cell culture system developed by NASA, I showed you with my lab student, well, you can get organoids, tissue spheroids such as this. That's what we've done, along with other pieces of research we've published. So we are trying to realize one of the goals of NASA, science in space, to cure diseases on Earth. And right now we're using microgravity for this purpose. Microgravity is Cool. The details of the research you can find in the descriptions down below. I'll do a few more episodes on each of these, but we've published 2 papers. One, the latest 2023 titled Simulated Microgravity-Induced Changes to Drug Response in Cancer Cells Quantified Using Fluorescence Morphometry. And then another one titled Microgravity Modulates Effects of Chemotherapeutic Drugs on Cancer Cell Migration. So a lot of tissue engineering using microgravity. And these are the fun people who did this fun research and also funded by NASA, not surprising. So in the future, what do we think? What do you think yourself? It's made in space already superior to what we have on Earth. There's a lot of potentials there in robotics, communication, manufacturing of drugs, so many. All right, I will be dealing with some of these in future episodes.